Hello! So, if you remember in the last video, we were talking about this thing up here. We were talking about polynomials. And we realised we've already met examples of polynomials before, didn't even know it. And then we said the highest power of a polynomial is called the order or the degree. We're interested in that because that tells us the amount of times that it crosses the x-axis. Now what I'm hoping to do in this video is talk about these things here, talk about quadratics. How do we actually solve quadratics? So remember, solving quadratics, all that means is that we're just finding where they actually cross the x-axis. And then I'm hoping to use those techniques, tweak them a little bit, and then try and solve these things down here, try and solve cubics. So let's take a nice, simple quadratic and talk about the number of ways and type of ways that we can solve this. So, first of all, I can't solve that as it is, right? Because remember when I'm solving it, what I'm saying there is where does it cross the x-axis? At the moment, that's just telling me what the equation of that parabola is, right? So what I'm going to have to do is I'm going to have to set it equal to 0. Why am I setting it equal to 0? Well, I'm saying now y is equal to 0. Where does y equal 0 on this graph? Okay, and the line y equals 0 is just simply the x-axis. Let me just write that again. It's just simply the x-axis. So I'm going to have to set all of that thing equal to 0. Now, to my mind, there's 3 ways which I would go about solving this. I'd either try factorising. Factorising the easiest one. If I can factorise it, Bob's your uncle, I'm away, I'm happy. Okay, I could also complete the square, right? Or I could also use the formula. Now, the thing is, the formula and completing the square, they come from the same things. You know, the formula comes out of completing the square. And if you've never seen the quadratic formula being derived from completing the square, boy, you haven't lived. What fun. Right, so let's try factorising first of all. So factorising, remember, all we're doing is we're just setting up a couple of brackets, okay? And we're hoping that when I multiply them out, they're going to equal my x squared plus 4x plus 3. So think about my factors of 3. That's why I have to multiply together to make 3 and add together to make 4. So 3 and 1, right? So I could put a plus 3 here and a plus 1 there. And lo and behold, that works. You can check it out yourself. Now, what I've found there are actually the factors. Let's just talk very briefly about that. Okay, so think about 6. What are the factors of 6? Well, there's a few, but I'm just going to write down one set. So I'm going to write down 3 and 2. They're an example. They're factors of 6, right? They're 2 numbers that multiply together to make me my 6. Okay, so in the same way, these 2 things up here, the fact I've got x's and 1s and pluses and whatever, they're just 2 brackets being multiplied together and they will equal my x squared plus 4x plus 3. Okay, so they're my factors, but they're not my roots. My roots are where it actually crosses the x-axis, right? So in other words, I'm saying I've got 2 things being multiplied together and they equal 0. So either x plus 3 equals 0 or x plus 1 equals 0. One of them has to equal 0. If I multiply 2 numbers together and it equals 0, one of them has to be 0. Fundamental theorem. Okay, so then I just solve that and I get x equals minus 3 or x equals minus 1. They're my roots, okay? So it's really important there to make the distinction. What I found there are my roots. Where do they actually cross my x-axis? Okay, but what I found up there were my factors, what multiply together to make my x squared plus 4x plus 3. Next method, completing the square. Nice and simple, we've done this hundreds of times before. Okay, I take my x, and I'm going to add it to something and it's going to be all squared. Well, what is that something I add it to? It's going to be half my 4, so it's going to be x plus 2 all squared. Okay, I expand that out and it better equal x squared plus 4x. So when I expand that out, I get x squared plus 2x plus 2x, that's my 4x. But I'll also get a plus 4 hanging along, right? I haven't got a plus 4 up there, so I'm going to have to take away a 4, and then the 3 comes along for the ride. Okay, so what's minus 4 plus 4? Minus 4 plus 3, that's just minus 1. Okay, then I'll just solve that as if it's an ordinary equation. So I've got x plus 2 all squared, take the 1 over the other side, so I get x plus 2 all squared is equal to 1. Okay, then of course I can take the square root of that. So I can take the square root of 1, okay, and I get the positive or negative root when I take the square root. Okay, what's the square root of 1? It's 1. Okay, so, and then I just take the plus 2 over the other side, so it becomes minus 2. So I get 1 minus 2, that's minus 1. Okay, so x equals minus 1. Or I get minus 2, take away 2, that's minus 3, isn't it? So I get x equals minus 2 or x equals minus 3 as before. And then, of course, I can use the formula. Might as well just stick it in. So x is equal to minus b. Well, what's my b? That's my 4. So x equals minus 4. Oops, I'll just move across. X equals minus 4 plus or minus the square root of what is b squared. So what's square root of b squared? Well, square root of 4 is 16 minus 4 times 1 times 3. That's minus 12, isn't it? And then it's all over 2a. So all over 2a, 2 times 1, that's just 2. Okay, so it's all over 2 there. Okay, so I've got that thing, 16 minus 12, that's just 4. Okay, so I've got 4 in there. What's the square root of 4? That's just 2. Okay, so I've got 2, cancel, cancel jobby. So I've got 2, a minus 2 plus or minus 1, okay, and then it comes out as x equals minus 1 or x equals minus 3 again. So can I use any one of these methods to try and solve cubics? Well, factorising, yeah, I could probably factorise a cubic, that's fine. Completing the square, well no. Can I complete the cube? Not really, okay? There is a formula for cubics, but it's long, it's messy, it's horrible. Don't even go there. I'm going to try and factorise my cubics.